Examples: swimming, entry, dive. The equation y is equal to x minus 9 squared minus 4 models the entry dive of a swimmer, where y is the height in feet of the swimmer's head and x is the distance away from the diving blocks, also in feet. First of all, let's graph the axes. They've told us that the y is representing the height of the swimmer's head. So we're going to label y as height in feet. We also know that x is also in feet, but it's the distance away from the diving block. Now, I'm going to superimpose a diver and a dive on it. And we have the parabola that it creates. Now, the first question I have, what is the meaning of the vertex? Well, the vertex is 9, negative 4. The x value tells us the horizontal distance, and the y-axis tells us the height. So it means that at 9 meters away from the diving block, the swimmer reaches the minimum height of 4 feet under the surface of the water. So our assumption is height is equal to 0 when we're speaking about the surface. When does the swimmer resurface? Now we know that since the surface of the water has a height of 0, then we would have y is equal to 0. So we're looking for the coordinate, an unknown x, and y as 0. Now I'm going to substitute y is equal to 0 and solve the equation. 0 equals x minus 9 all squared minus 4. 4 equals x minus 9 all squared. Square root of 4 is equal to x minus 9. 2 is equal to x minus 9. 2 plus 9 is equal to x, and x is equal to 11. So the swimmer resurfaces 11 feet away from the starting block. Another example now. We have a grasshopper. The grasshopper jumps off a twig. The height, h in centimeters, of the grasshopper above the ground after t seconds is modeled by the function h is equal to negative 100, bracket, t minus 2/3, close bracket, squared, plus 69. Now let's draw our axes again and label it. So I know that we've got a y-axis of height in centimeters and an x-axis of time in seconds. Now I can look at the equation in vertex form and say I know that the vertex is going to be 2/3 69. That means that we're going to be in the first quadrant, and I'm going to have a parabola that looks somewhat like this. When does the insect reach its maximum height, and what is the maximum height? Well, we have already identified that the vertex is 2/3 69. So interpreting that, we can say the grasshopper reached 69 centimeters, which is the maximum height, 2/3 of a second after taking off. Part B, what was the height of the twig? To find the twig's height, we have to know the height of the grasshopper at takeoff. So when t is equal to 0 would give us the grasshopper sitting on the twig. Let's substitute that in. H is equal to negative 100 times 0 minus 2/3 squared plus 69. Let's keep going. H is equal to negative 100 of 4/9 plus 69. H is equal to 24.6 centimeters. I just put that all into the calculator at one time. So the twig was approximately 25 centimeters high. Now, part C of the question. When did the grasshopper land? We know that when the grasshopper lands on the ground, the height is 0, or h is equal to 0. So now we're looking for the coordinate of some unknown number and 0. Let's substitute 0 in for h. 0 equals negative 100 x minus 2/3 squared plus 69. Let's rearrange. Negative 69 equals negative 100 times x minus 2/3 squared. Let's simplify it by dividing. Negative 69 divided by negative 100 equals x minus 2/3 squared. Let's continue by taking the square root. Square root of 69 over 100 equals x minus 2/3. Square root of 69 over 100 plus 2/3 is equal to x. Now put that all into your calculator, and we have x is equal to approximately 1.5. So we know that the grasshopper lands 1.5 seconds after it's taken off.